a parallel series circuit. To get the R equivalent between A and B, firstly we are going to start with the right side of the circuit, which is 5 ohms and 6 ohms. As you can see, the combination of 5 ohms and 6 ohms is in parallel. Then we are going to separate and withdraw the circuit, and it will become like this. We are going to label this node as VA and this node as VB. So the potential voltage of 5 resistor will be VB minus VA, and the potential voltage of 6 resistor will also be VB and minus VA. Therefore, the combination of these two resistors is in parallel. So, the calculation for parallel is 5 times by 6 over 5 plus 6. So, the total for this calculation is 2.73 ohms. To find the R equivalent for parallel, the calculation will use this symbol. This is the symbol of a parallel equation. Then we redraw the circuit exactly like this. The last second step is redraw the circuit into series. 4 ohms is the value given for resistor, and both of these value is from parallel. So the calculation for series circuit is Req equals to 4 plus 0.55 plus 2.73. So the total is 7.28 ohms. Next, the circuit will be reduced according to this. Both of these resistors is connected in parallel. Therefore, the R equivalent for this parallel is 7.28 times by 7 over 7.28 plus 7. So, the total R equivalent between A and B is 3.57 ohms.
So this is the last question, which is a sample question of delta to Y transformation. This 3 resistor is connected in delta, so we will transform into Y by creating an extra node here and drawing resistor into Y transformation like this. Then we will label this resistor with R1, R2 and R3. Each resistor in the Y network is the product of the resistors in the two adjacent branches divided by the sum of 3 resistors, which means for R1 the formula is R1 equals to the resistor adjacent to R1, which is 5 and 2, 5 times 2 over the total of 3 resistors, which is 3 plus 5 plus 2. Then we get the total of R1, which is 1. And then we do the same for R2. The resistor adjacent to R2 is 5 and 3. And then we divide it by the total. Then we get 1.5 ohm. The same goes to R3. Then the total of R3 is 0.6 ohm. Then we will only draw these three resistors back into the original circuit, like over here. So this is the circuit that we had put back into the original circuit. This is R1, this is R2, and this is R3. So we will use the series and parallel formula to find the R equivalent. The first step is 5 and 1.5 is connected in series. The same goes to 5 and 1. So to find the R in between the two of them is we only plus the two resistors together. For example, 5 plus 1 equals to 6, and the other one is 5 plus 1.5 equals to 6.5. And then the circuit will change into this. The next step is 6 and 6.5 is connected in parallel. So we have to use the parallel formula to calculate the R equivalent. 1 over R equals to 1 over 6 plus 1 over 6.5. The total is 3.12. And then 3.12 and then 3.12 is connected with 0.6 in series. So we just add them up and we have the R equivalent for the circuit.